all in and give you the type and then
Yeah, sure. Yeah.
types, and then you can see how they're arranged. So uh first one is called difference of squares. This one is also difference of squares. This one down here on the right has the appearance. I'm sorry, it is difference of squares. Sorry, I was thinking of something else. Squares, difference of squares, like that. Let me see here. The next one. So this is a GCF followed by an A equals one. A equals one, A equals one, A equals one. This is considered a perfect square trinomial slash A not equal to one. This is an A not equal to one, A not equal to one, and an A not equal to one.
Got it.
Okay, so you tell me which ones you want us to do. Let's call it, give me like row and column here at some point. Like maybe you already know how to do all the A equal ones. We don't need to do those, but there's only two.
Let's maybe
Actually,
do
actually, hang on. I didn't look at this one. This one could be prime. Do you have an answer key to this? No. Okay.
okay, let me check because that
This
one's
one's not. It's not. There's also the possibility that's prime, which is really weird, unnecessary in this course.
so
But
that one is x. I got x plus 16
yes,
and x minus
exactly.
4.
Yes, that's
That's what the
correct.
teacher got too. So
Yes, that's correct.
I'd like to over the one in row 2, column 1, like the
The perfect square trinomial. All right. So what I'm looking for, I said A not equal to one because it is true, but what it is that if you can take the square root of the first one and the square root of the last one, you multiply them together, and then you double it, and if that is plus or minus the middle term, it is a perfect square trinomial, which it is. So perfect square trinomials always have this form: a squared minus 2ab plus b squared. And then they always factor into a minus b squared like that. In your problem, this would be a, and this would be b. So it becomes 6x minus 1 squared like that.
yeah, I think you're correct. Yeah.
Okay. The other one you have to remember here, which is, I still have not, I mean, I haven't had enough time to like look at both your review and your actual test, but your teacher might switch to the other one. This becomes a plus b squared. This would be a good thing to have on a note card, you know, even if you don't get a reference sheet, something you put on a reference sheet and you look at it the whole time while you're studying.
Got it.
Okay. So yeah, go back to that, list here. Do you see another one here you want us to look at?
Why don't we go look at uh row 2, column 2, 10x minus 13x plus 3.
So the leading coefficient being a constant besides one gives away what the type is. You also want to always be on the lookout for a graded common factor that goes into all three of them. And that's where row 3, column 2, like it has the appearance of being kind of like the one you did, but -3 goes into all of them. So you want to just
Yeah,
be on the lookout for. That's a time-saving thing that you need to get help with. So in this case, you take the first number and multiply it by the last one, which includes the sign. 10 times 3 is 30. You're looking for two numbers that multiply to 30 but add to negative 13. That's the key there. They add to negative 13.
Um, 30. It is six. Actually, never mind. That would be 11. Um, 5. I was thinking about 6 and 5, but 6 and 5 won't add up to negative 13, even if one of them were
Yeah,
negative.
this is where
So,
you got to be the kind of the engineer where you just go through all the
yeah, so
possibilities. All right, it's 1, 2, 3, and 10,
2 and
5, and
15 would
6.
probably work because there's
It does
negative
work,
15 plus
but
2.
you have to do one, but they have to both be negative or both be positive.
Oh, yeah, because of the signs.
Yeah.
Got it.
So now you figure out which pair is better with the 10x squared. Is it the minus 3 or the minus 10? And hopefully you'll say it's the minus 10x
Yeah,
pairs better with that.
then you take out the 10x on that side.
Yes. And then if you've done it correctly, when you
You
put
can
whatever's in
multiply it by
parentheses there,
negative 3.
there you go. It should work. And that's the idea.
Yeah.
Unless it's prime, which we haven't seen. All right. That's a good one to do. Number row 1, column 3 would be one like it. Yeah, it's kind of good difficulty.
Yeah.
All right. Totally up to you what we do next. We've covered two of the types. I'm guessing perfect square trinomials are clear.
Yeah. Um, One of the ones that I wanted to go over is a little bit more down the
Sure.
paper.
Yeah.
Number 3. So what is number 3 in the quadratic formula?
Oh, oh. Solved by completing the square and by quadratic formula. Well, that's horrible. Can we just give up? All right. All right, there's a bit to do before you can use quadratic formula. Like it's not even close to being in the right form. It's got to be in the form ax squared plus bx plus c equals
So you have
0.
to expand everything until you
Yeah,
get the standard form and then bring everything over to one side, right?
yeah, exactly. So let's uh let's look at this. Make sure you write out this unless, at some point you might get comfortable with how to do this, like you might be able to just write these out correctly. But until you are, I probably would just write it out. Um, so that but now just the foiling. I mean, just a lot of work here. So let's get going on that. Um, 6x plus 1. All right, so we got 9x squared minus 30x plus 25 plus 14x minus 22. And then we got 36x squared plus 12x plus 1 plus 2. God, this is really crowded. Don't like this at all. All right, and then I guess we're gonna go right. Well, let's clean up some things. So it's 9x squared minus 16x plus 3. So we're gonna go right, minus 9x squared. Huh, that worked out nicely. I wonder if that was the intent here. 27x squared plus 28x. Why would your teacher want you to do quadratic formula on this problem? Did I miss anything here, Karthik? I mean, please let me know if you see something that doesn't look right.
You did the following, and then minus 30.
It looks okay to me.
Yeah, it didn't look like anything is off.
All right,
I think
let me do one more thing to check this. Because this is actually where I'd rather you go talk to your teacher and say, teacher, I was working on this and it gets down to this, and
um
this
yeah,
doesn't look like quadratic.
I just saw the key that she gave for it. What she did is she put that into a quadratic formula, the x equals negative b over 2a, and
Yeah.
then put
Oh,
c as 0.
right. And you can do that. It's just weird. Like it's really weird. Yeah, this is correct. Yeah. So, okay. Well, so A equals 27, B equals 28, C equals 0. So, all right, I apologize for that. So, yeah, X equals minus B plus or minus the square root B squared minus 4 times 27 times 0
And it
all over
cancels out,
2.
of course, because with the 0,
Yeah.
so it would
So
just be
it's not that bad. It's just weird. You know, it's like doing something that let's like you would never do. I don't know. I don't have a good example, but anyway, this ends up being minus 28 plus or minus 28 over 56. Um, oh, sorry,
yeah, I
this
got
is
the same.
sorry, it's 27. Sorry, 27. I got the wrong number there. All right, and so it either ends up being minus 28 plus 28 over, sorry, 54, not 57, 54. Or it ends up being minus 28 over 54, which is minus 56 over 54. This first one is 0. This ends up being minus 28 over 27. That's your second answer.
Yeah. let's see.
All right, any questions on that?
No.
Okay. That was weird. It's like your teacher's choosing for you to use the wrong method for a problem. Like that's the style. So like four is a good question because you have to sort of pick the method. We could talk about like what you might use to do these. Like what makes the most sense and why. Yeah, like it's kind of grouping these together. So let me actually do this. I guess I think I can squeeze them all in here. Yeah. So like the first one is the square root property because x only appears in one place, only appears once. Same with this one down here. This would be the square root property, or square roots, I guess your teacher calls it. You kind of see how that's the logic between those. If it only appears, and then this middle one here as well. Tic-tac-toe. All right. Then the next one is factoring. So you'd have to you have to do some work to factor some of these. So I can't tell you I can't tell you which one would potentially factor until we like expand this. Like this one, you can't decide in their current forms is the point. Like I'm guessing this one probably factors. This one probably factors down here, and maybe this one, but I'm not sure until we do like another step. Now completing the square, that's this one over here for sure, for sure. Is that okay? Completing the square on that one because of
Yeah, yeah,
the
because
six
the
x.
X, yeah.
But it may be that one of these other ones like ends up being that like after you like the one on the bottom here, if you multiply everything by 2/3, you end up getting x squared plus 20x minus 8 equals 0. And that's another good candidate for completing the square because it doesn't factor.
By the way, if you scroll up a little bit, the middle third one, 3x squared, 3x minus 2 squared plus 5x equals 6. Wouldn't that be completing the square if you were to uh, expand the
I
a
don't know. Let's
minus
take a
b
look.
squared?
So it's 9x squared minus 12x plus 4 plus 5x equals 6. So then this becomes 9x squared minus 7x. Bring the 6 over. It ends up being minus 2.
Yeah,
Uh, this is an A not equal to 1 problem because the 9 times the negative 2 ends up being negative 18.
got it.
And that one does work. And again, you can't tell until you expand it. Now, the reason I would not do completing the square is the leading coefficient of 9 is bad. Making it worse is minus 7.
Couldn't you do AC B then factor it? Can't you
I'm sorry,
factor
which
that?
one? Which one?
The one that you're just working on?
This one right here?
Yeah.
Yeah, it's an A not equal. You multiply the 9 and the negative 2. 9 times negative 2 ends up being negative 18. And then you're looking for two numbers that multiply to negative 18 but add to negative 7, 2 and negative 9. Do you want to keep going factoring that from there?
Yeah.
Okay.
Um, I got x equals 1 and x
Give me
equals -2/9 after
give me
only.
Give me your factors. What did you end up getting?
X minus 1 and 9x plus 2.
Okay, so the reason I'm asking for this, I can quickly foil this to tell you if you're correct, and you are very good. So you're right. X is 1 or -2/9. Very good. All right. Any of these other ones you want us to look at? Or do you want to maybe expand, like, expand this one and bring the 60 over, or same thing over here, expand both sides in the lower left?
Mm. So what was that? Okay, that's your equation. I'm gonna add in here. Here. Okay. Okay. Right. So back Wait, so did he factor the equation?
Which one? Top middle or the one on the left or left, lower left?
The top middle.
Yes, you can factor it. 10 and -7 get you to -70.
I think I tried to complete this square for some reason.
Bad,
Yeah,
bad strategy on an odd number if you can avoid it. I mean, I was
yeah,
looking at
because
that
I
too,
thought
but
the
it's,
fraction,
yeah. I mean, it does work. It's just you're adding more work
fraction
if
to
you're,
it, yeah.
yeah. So if you avoid that, the reason I put completing the square on the left is that it doesn't factor because it's not, when this number is smaller than the middle number, when the C is smaller than the B, you're in big trouble. Um, and because it's even, that's a better choice to complete the square because you can cut it in half.
Uh,
Yeah, what else do you want us to talk about on this kind of grouping?
um, I feel like that one on the top left is pretty easy, because you just have to subtract it or add it on both sides, add 5 on both sides, and then
Yeah,
divide it and do that. It's kind of the feeling for down there, because you're just trying to get it to solve a square root.
yeah, the one on the lower right though, I want to bring that one up because it's when you subtract 9 from both sides here on the lower right, you get a negative number. And you
Yeah.
can take the square root of a negative number. Your answers, you have complex solutions, with I in them.
uh, Then you would, yeah, so when you take the square root, you get like 2i
Yeah, plus or minus.
plus or
Plus or
minus. Yeah.
minus 2i. Yeah, the square root of -4 is really the square root of -1 times 4. Square root of -1 times the square root of 4. And so your answer doesn't look great. I mean, you add 1 to both sides. I
You just
like
divide it
that
by
number.
35.
Yeah, it's 1 plus or minus 2i, and then you divide both sides by 35. And then sometimes what happens is they want you to write your answer in
Yeah,
this form, a plus bi.
yeah. So there was a question in class that somebody asked if it's like, for example, 1 plus or minus 4i over 2 or something like that, then you would have to simplify that into uh 1 over 2, then yeah. Plus or minus.
Yeah.
Yeah, yeah.
That's a small thing. Like if you're running out of time, I wouldn't worry about it. But it's
Yeah, she
could
did
be.
say that she wanted it to be like in the simplest formula, so should be
Well, of
something
course,
down the
but
final answer,
you
yeah.
got you got a lot. You're gonna have a lot of time pressure, so just do the best you can.
Yeah.
Okay, was there another one in this grouping that you wanted us to look at?
Um, uh, No, I think the other three are pretty easy. The other four are pretty easy.
Okay, what about, we skipped over, two, leaving the square, maybe you don't need that. Five, lots in five we could do. Um, any in five that you want us to look at?
Um, five, maybe maybe the bottom middle one on
Okay,
number five.
sure. That's good.
Yeah, the one that's 4 - 2i over 7 - 3i.
Yep, that's good. That kind of incorporates a lot of things that would come up here. You always multiply the top and the bottom by the complex conjugate, which is in this case 7 plus 3i. The only thing that changes is the operator. Plus goes to minus or minus goes to plus. Top and bottom by the same thing. So you have to FOIL. So I'll FOIL why don't you FOIL the top? The bottom always, always, always turns into a number. Why don't you FOIL the top for us, please? Hey, I'm sorry, maybe you didn't hear me. Did you, I want you to FOIL the top. Apologize if I didn't say that. Let me know what you come up with for the top, please.
I got 34 plus 2i.
Okay, so you said 34 plus 2i, like that?
Yeah.
Okay, let's take a look here. So it's 28 plus 6i minus 14i minus 6i squared. So I get a different middle number. Make sure that I did it. Oh, I misadded here. It's 4 times 3 is 12i. So I got minus 2i. So I see that at the top becomes 34 minus 2i because you've got positive 12 and negative 14.
Oh yeah, it is -2. Yeah.
Okay. The bottom, you can see the O and the I, they cancel. And then it becomes 49 plus 9 because I squared is -1, just like you did in top. So your bottom becomes over 58. And so again, you gotta divide 34 divided by 58 minus 2 over 58i. Something like that. Yeah, actually check this one. Another piece of software I've got. Teacher's not doing you any favors here by making these nice. Yeah, that is the correct answer. Yeah, questions, thoughts on that?
No, I think I got that. No. Yeah.
Why don't you try the top right one on your own, the 5i over 3 plus 4i? Or I can make one up like this one for you to try. But this is a good one to try if you want.
Only the one. All right, I got 15 minus 20i over 25. It could probably be simplified.
That sounds pretty good here. Sorry, I didn't realize you're gonna have that already. Let me quickly. So that you said give me your answer one more time.
So I simplified it down, so it's 3 minus 4i over 5.
Uh did you multiply the top and bottom by 3 minus 4i?
Yeah.
Okay. So there are no negatives in your answer. It's 15i minus 1pi squared, which ends up being 15i plus 20.
Oh, I put 20i to the I squared. That's square that. Yeah. Then it would have been 15 plus 20.
And then the
20i plus.
bottom becomes 9 minus 69 squared, which is 25.
Yeah, I think it's for the I squared. But
And
the
then it's a
negative.
small thing, but you got to switch the order. It's 20 over 25 plus 15i over 25, and then simplify. I'd really like to have you do one more of these. I don't know if you're up for it, but um, I do think you've got to try one more while we're together here. Is that okay if I give you another one to look
Yeah,
at?
yeah, sure.
All right, so let's go 3 minus 2i over 1 plus I.
All right, I got 1 minus 6i over 2.
It's got to be in this form, a plus bi. So what's the first fraction?
1/2.
1/2. And then what did you say next?
Minus 6i over 2, or
We got
minus 6 over
5
2i.
over, we got 5 over 2. Let's take a quick look. 1
Oh,
minus I,
yes,
1
you.
minus I.
I multiplied the negative instead of subtracting, and that's why I got the negative
Yeah.
6 instead of -5.
So it's very common for them to have the same fraction denominator. Pretty common. Not always, but pretty common. So that's maybe a check here. I do think this question on the bottom here is good. It's kind of like for you to think about, like we just did a lesson on a lot of things. You're like, maybe it this way, like what do you feel strong about and what do you feel weak about? And we did a number of factoring problems. Completing the square, quadratic formula. There's a number of things here that you might say you feel good about, don't feel good about, feel better at. Um, Talked about the square root property. Maybe that's how I would look at this last question is like, basically it's telling you where do you need to spend more time studying on this thing. All right, so now you sent another one over. I guess this is maybe part 2. Got time for maybe a problem or two. So let's do number 1, unless you've already done that in class, or number 3.
Uh, okay.
Any preference on that?
uh, we can do number 3. Yeah.
Okay. First thing I would do is graph it and see like how many intersections there are. Just as like a guy, like because your time is limited when you're studying. I know you won't have it on the test, but that would be a consideration. So I would solve the second equation for y squared. So you end up getting that y squared equals 2x squared minus 10. And that will go in for y squared like that. So you've got x squared plus 2x squared minus 10 minus 3x equals 8. So this becomes 3x squared minus 3x minus 18 equals 0. Factor out of 3. And then you end up getting x minus 3, x plus 2 equals 0. X is 3, x is -2. And then you go back to your y squared equation to solve. So y is equal to plus or minus the square root of 2x squared minus 10. And you put each of those in. So you start out, okay, well, if x is 3, y is plus or minus 2 times 3 squared minus 10. So that's 9. 3/4 is 9 times 2 is 18 minus 10 is 8. So it's plus or minus the square root of 8, which is plus or minus 2 root 2. So you end up getting 3 comma 2 root 2 comma 3 comma -2 root 2. And then for the other one, 2 times -2 squared minus 10. That one doesn't work because you end up getting the square root of -2. So there ends up not being any solutions to that. I know that was really fast, but that is process. It's mostly substitution, mostly. Number 2 is an elimination problem. Same with numbers 4. We can certainly pick up there. Like, even though your teacher said you can use a calculator, we did this by hand, which is really the expectation. I don't know if there's any you have to use the calculator on. All right, we're going to stop there for today, Karthik. So catch you in tomorrow at